Hello guys, my name is Shayogiri. I'm an intern at Intellify, and in this video we'll implement random forest for classification using Python in Jupyter Notebook IDE. In the previous video we had implemented random forest for regression. In this video let's use the same algorithm for classification. So let's look at the problem definition. The task here is to predict whether a bank currency note is authentic or not based on four variables, that is variance of the image, wavelet transformed image, skewness, entropy, and kurtosis of the image. This is a binary classification problem, and we will use a random forest classifier to solve this problem. Steps followed to solve this problem will be similar to the steps performed for regression. I hope you remember the steps for regression. Let's look at the snapshot of our data set. It has 5 columns. These 4 columns are the input features or the independent variables, variance, skewness, kurtosis, entropy, and class represents the target variable or the response. As it is a binary classification problem, so the output variable consists of 2 values, 0 and 1. So the data set is described as data were extracted from images that were taken from genuine and forged banknote-like specimens. For digitization, an industrial camera usually used for print inspection was used. The final images were 400 x 400 pixels due to the object length and distance of the investigated object. Grayscale pictures with a resolution of 660 dpi were gained. Wavelet transform tool were used to extract features from images. This is how the dataset was constructed. So let's move on to import the necessary libraries. Import pandas as PD, import numpy as np. So what are pandas and numpy? NumPy, which stands for Numerical Python, is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed. That is, we can perform addition of 2 arrays, difference of 2 arrays, array transpose, and so on. Pandas is a high-level data manipulation tool developed by Wes McKinney. It is built on the NumPy package and its key data structure is called the data frame. Data frames allow us to store and manipulate tabular data in rows of observations and columns of variables. This data frame is the most important application of the pandas. Now these PD and NP are the aliases. PD is an alias for pandas and NP is an alias for NumPy. So let's move on to import the dataset. Dataset equal to pd.read_csv, and we give this argument. This is the location of the dataset, and bill authentication is the name of the dataset. .csv is the extension. CSV stands for comma separated values. So my dataset has been downloaded into the Intellify folder of the online courses, internship and more folder within the drive. As you can see from this path, you will need to change the file path according to your own setup. So we import our dataset and store it in a variable named dataset. To get a high level view of the dataset, we execute the command dataset.head. So this head function displays the rows of the dataset. By default, dataset.head gives the first 5 rows of the dataset, but we can pass an argument inside head function like dataset.head10, which displays the first 10 rows of the dataset. Dataset.head15 displays the first 15 rows of the dataset, and so on. Now let's have a brief look at our features: variance, skewness, kurtosis, and entropy. The first input feature, variance, is described as variance of wavelet transformed image, and it is a continuous variable, as you can see. Second column, skewness of wavelet transformed image, which is also a continuous variable. Third input feature, kurtosis of wavelet transformed image, continuous. Fourth input feature, entropy of entropy of image, which is also a continuous variable. And this target variable class is a discrete variable integer receiving the values 0 and 1. As with the case of regression dataset, values in this dataset are not very well scaled either. As you can see, these values differ vastly from one column to another. The dataset will be scaled before training the algorithm. As we know that scaling the dataset gives better predictions, so we'll scale the input features before we train the random forest algorithm. We prepared the data for training. The following code divides data into attributes and labels. X equal to dataset.dialog. This first selection, as we know, is a row selection, and this selection, as we know, is a column selection. So at first in X, we select these 4 input features, that is all the rows where the column indices are 0, 1, 2, 3, and in Y we select this column, that is the class for the output variable. So in Y we select all the rows where the column index is 0, 1, 2, 3, 4. The following code divides data into training and testing sets. After extracting the input features and the target variable, we have to split our data into training set and testing set. This simple block does this automatically. First, we import this train test split module from sklearn.model selection, and we split the data by writing this statement. X and Y respectively represent the input features and the target variable. Test size equal to 0.2 means we use 20% of the data of our available data to test or validate our model, and 80% of the data to train our model. We set a random seed. We set a random seed like random set equal to 0, so that every time we run a model, we will get the same output. We proceed to scale the values of the input features. We import the standard scalar module from sklearn.preprocessing. We create an object of the standard scalar class and scale xtrain and xtest by writing these lines. sc.fit transform xtrain, we use fit transform because we fit our model on the training set, and sc.transform xtest. So after this code, the input features in the training as well as the testing set are scaled so that their means are 0 and standard deviations or variances are unity. Now after scaling the data, we proceed towards training the algorithm. In case of regression, if you remember, we used random forest classifier. We imported the random forest regressor class from the sklearn.ensemble library. In case of classification, we import the random forest classifier class from sklearn.ensemble library. Ensemble because random forest is an ensemble of many decision trees. It is a bagging technique. So we create an object of the class random forest classifier class in estimate is equal to 20, means that we will use 20 decision trees, and we said generate a random seed. In case of regression, we use random forest regressor class of the sklearn.ensemble library. For classification, we will use a random forest classifier class. Random forest classifier class also takes n estimators as a parameter, like the random forest regressor class. Like before, this parameter defines the number of trees in a random forest. We will start with 20 trees again. And finally, we get the predicted values on our input features in the testing dataset. Later, we will compare these predicted values with the values y test to get the accuracy of our model. After training the data and getting the predictions, our next step is to evaluate the algorithm, how our algorithm performs on the training, on the testing set, and so on. For classification problems, the metrics used to evaluate an algorithm are accuracy, confusion matrix, precision recall, and F1 values. We will get to know each of them one by one. As in case of regression, you know our performance metrics were MSE, RMSE, MAE, etc. But in case of classification, the metrics are accuracy, confusion matrix, precision recall, and F1 values. First, we look at the confusion matrix. From sklearn.metrics, we import the confusion matrix module and print the confusion matrix. So the confusion matrix looks like this. So what is meant by a confusion matrix? A confusion matrix is a summary of prediction results on a classification problem. The number of correct and incorrect predictions are summarized with count values and broken down by each class. This is the key to the confusion matrix. The confusion matrix shows the ways in which your classification model is confused when it makes predictions. It gives us insight not only into the errors being made by a classifier, but more importantly, the types of errors that are being made. So let's look at what each element of the confusion matrix represents. So this is a generic confusion matrix where TP represents the true positives, FN false negatives, FP false positives, and TN true negatives. Here class 1 is the positive class and class 2 is the negative class. Let's look at the definition of these terms. Positive P, observation is positive. Negative N, observation is not positive. True positive TP, observation is positive and is predicted to be positive. False negative FN, observation is positive but is predicted negative. True negative TN, observation is negative and is predicted to be negative. False positive FP, observation is negative but is predicted positive. So comparing the confusion matrix obtained in this problem and the generic confusion matrix, we see that TP equal to 155 in our case, FN equal to 2, FP equal to 0, and TN equal to 18. This FP plus FN represents the total number of misclassified cases. So in our case, we see that we have only 2 misclassified cases. So not objectively but subjectively, we can say that our algorithm or model performed satisfactorily. Just an intuition. In this example, there are 155 true positives, 2 false negatives, 0 false positives, and 118 true negatives, as we have just seen by comparing these two matrices. Here there are 2 clear cases of misclassification. This FP plus FN. Now let's evaluate the performance metrics. Classification rate or accuracy. Classification rate or accuracy is given by the relation accuracy equal to TP plus TN by TP plus TN plus FP plus FN. However, there are problems with accuracy. It assumes equal costs for both kinds of errors. A 99% accuracy can be excellent, good, mediocre, poor, or terrible, depending upon the problem. So here, after plugging in the values of TP, TN, FP, and NN, we achieve an accuracy of 99.27%, which is extremely high. So we might tell our algorithm performed satisfactorily, but we have to look at other performance metrics also. We look at another metric called recall. Recall equal to true positive by true positive plus false negative. How do we define recall? Recall can be defined as the ratio of the total number of correctly classified positive examples divided by the total number of positive examples. High recall indicates the class is correctly recognized. Small number of FN, false negatives. So after plugging in the values of TP and FN, we achieve a recall of 98.726%, which is also high. Let's look at another performance metric, that is precision, which is equal to TP by TP plus FP. To get the value of precision, verify the total number of correctly classified positive examples by the total number of predicted positive examples. High precision indicates an example labeled as positive is indeed positive. A small number of false positives. Here we get a precision of exactly 100%. That is, we get the maximum possible precision. High recall, low precision. This implies that most of the positive examples are correctly recognized, no false negatives, but there are a lot of false positives. Low recall, high precision. This shows that we miss a lot of positive examples, say false negatives, but those we predict as positive are indeed positive, low false positive. Here we have high recall as well as high precision. So we can tell that our algorithm has done a very good job. We have achieved high accuracy as well as a high recall as well as the perfect precision. Now we combine these evaluation metrics into a final metric which is called F measure. Since we have two measures, precision and recall, it helps to make a measurement that represents both of them. That is, we combine precision and recall. We calculate an F measure which uses harmonic mean in place of arithmetic mean, as it punishes the extreme values more. The F measure is simply the harmonic mean of precision and recall. That is given by 2 into recall into precision by recall plus precision. Here, our F measure comes out as 0.993, which is extremely high. So we can say that our model, the random forest algorithm, has been very successful in acting as a classifier. We have achieved a very high F value. So this is all about the case of classification using random forest algorithm. Let's have a brief recap of what we have done. We imported the necessary libraries, looked at the dataset where there are 4 explanatory variables and 1 dependent or response variable, which is a discrete one, 0 or discrete variable having the values 0 and 1. We imported the dataset, looked at got a high level view of the dataset, scaled, extracted the input features and the dependent variable from the dataset, and split our dataset into training set and testing set such that 80% of the data will be used for training and 20% will be used for testing. You can play around with this data. You can, instead of 0.2, you can specify 0.3. In that case, 30% of your data will be used for testing, and 70% of your data will be used for training. Next, we move on to scale our data such that the features, input features have means 0 and unit variance or standard deviation. After scaling the data, with the help of the scale values of the features, we train our model and get the predicted values. Next, by using the predicted, we comparing the predicted values and the values of the response variable in the testing set, we take a look at the confusion matrix and evaluate the performance metrics like accuracy, recall, precision. And finally, by combining the recall and precision, we get an F measure which comes out as 0.993, which is extremely high and is close to 1, which implies that the random forest algorithm has largely been able to classify the data with only a handful of misclassified cases. Thus, we get a very good predicted result by using this algorithm. So that's all about classification using random forest algorithm. I hope you guys enjoyed it, and thank you.